Our first problem is about a warehouse sorting machine. Imagine it has a 70% chance of correctly sorting a package. The machine processes 10 packages in one go. What's the probability that it correctly sorts exactly 7 packages? Now, let's identify what we're solving. We're looking for the probability of exactly 7 successes, correctly sorted packages. This is a PDF, probability distribution function question, because we want to find the probability of one specific outcome. So what we need to do is we need to turn on the calculator and then we need to press second vars. When we have done that, we need to select Binomial PDF. We need to input N, P and X, which is going to be 10 is the number of trials because there are 10 packages, P 0.7, which is the probability of success, and 7 is the number of successes we want. Press enter and the TI-84 will give you the probability. So the probability of sorting exactly 7 packages is going to be the answer to this problem. Next, let's look at a question where we need cumulative probability. Same scenario. A sorting machine processes 10 packages and the chance of sorting each package correctly is still 70%. What's the probability that it sorts at most 6 packages correctly? At most 6 means 6 or fewer packages. That includes 0, 1, 2, 3, 4, 5, 6. This is where we use cumulative distribution function or CDF because it adds up probabilities for all of the outcomes from 0 up until the number specified, in this case 6. So again we're going to go on to second vars, but this time we are going to select CDF. Once we've selected CDF, we are going to do the same thing, 10, 0.7, but this time we write 6 because we want 6 or fewer successes. So this shows us the probability of sorting at most 6 packages correctly. This time we're going to tackle the common question where you need to calculate the probability of at least. This time let's imagine a basketball player who has a 60% chance of making any given free throw. So when we do this, at least 6 means 6, 7 or 8 shots. 6, 7 or 8 shots. What's the probability that he makes these at least 6 shots? So to calculate this, we need to do something called the complement. The complement is as follows. We need to do 1 minus the probability of at most 5 shots, because the calculator can't do at least very easily. So as before, we're going to do trials is 8, we're going to do P is 0.6 and successes is 5. So once we have both or all of those numbers, we're going to type in binomial CDF, type that in, and then that will give us an answer. But that is not our final answer. Let's call this answer y. Our final answer is going to be 1 minus y, which will give us the answer to the problem. So I hope that was more useful, and good luck with the rest of your questions.